Okay, 2.2 basic differentiation rules. As we go through this, you guys need to write your notes, but you also need to find yourself, I don't know if you want just another piece of notebook paper or something that you write your differentiation rules on, okay? By the end of the year, you will probably have a notebook piece of paper, front, if not front and back. But I don't know if it necessarily needs to be like I'm writing in my notes and on my rule sheet. Like when you're doing your homework, after we've done 2-3 days of it, write it. And then the next time we get more rules, rewrite it and decide what you can take off of it. Because after, like we do most of the ones today, the constant multiplier, the power rule, the constant rule, the sum and difference rule, all of those things sound like they're lots of stuff. But after you do it for a week, you're like, I won't even need that on my sheet. Okay? So just as we go through things and add more and more rules, you want to start thinking about that. And I'll keep bringing it up. So.
But we are supposed to.
Yes, but I'm telling you, every time you write something on, you need to revamp it. Or you need to revamp it every once in a while because you're going to put things on there, but you're going to use them so much. It's a waste of your effort to look on the sheet with it and to write it down. Does that make sense? You only want on the sheet what you have to have on the sheet. Because if you have everything on the sheet, it will be overwhelming and you won't be able to find anything.
So like, is this something that would go on the sheet?
Well, the derivative of constant is 0. That's what that says.
Okay.
Okay. So the constant rule, ew, it's black pen. The constant rule is d dx of a constant, c, is 0. The rest of it is just proofs, so just don't go writing them all down. Okay, so the proof of that is if I did the limit method and I plugged it in, d dx of c, so f prime of x is the limit of change of x approaches 0 of f times x plus change of x minus f of x over delta x. If you plug it all in, you get c minus c, which is 0, and 0 divided by the change of x is 0. Okay, what we're finding is the slope of the tangent line, yes? Mm-hmm. So a constant is a horizontal line. So what's the slope? 0. There's no tangent line to a horizontal line, is there? Other than it. And then down at the bottom, we have the derivative of y. So dy dx equals 0, f prime of x equals 0, s prime of t equals 0, and y prime equals 0. I put this on there so you could see the different connections on how you would write them. See that?
Yeah.
But they're all constants.
Yes.
Okay. The next, the power rule. This is how I was doing the derivatives the other day so quickly.
Reminder, the girls need them in the girls' locker room. The final call if you need to get something out of there. After 2:30, you won't be able to go in there the rest of today. Train of the girls going in the girls' locker room.
Okay, so this is how I was doing the problem so quick earlier. So the power rule, d dx of x to the n is n times x to the n minus 1. So what does that mean? The exponent came out front, and you took 1 away from the exponent. That's it. So that whole long limit way I was making you do it, you could do it in about 30 seconds.
Okay.
So if I have f of x equals x cubed, so f prime of x. Not negative 1 prime. I said prime and I wrote negative 1. F prime of x is 1, because there's a 1 in front, yes?
Yeah.
Actually, I'm jumping ahead.
Oh, stop.
Okay, 3x to the second.
Yeah.
Okay, in part of your assignment it says rewrite. This is the rewrite. We need to change the cube root into an exponent. So what exponent is the cube root?
What exponent is the cube root? 1/3.
1/3. So bring the exponent out front. So g prime of x equals 1/3 x to the
1/3. -1 negative.
minus 1, which would be 3/3. So it'd be negative 2/3. And we all know it's such a bad idea to keep a negative exponent, right? So when we have a negative exponent, it reciprocates it, yes? So g prime of x equals 1/3x to the 2/3. Now, how did that happen?
You just did it.
No.
You
Or-
kept the denominator, you kept a fraction of 1/3 and moved the x and its associated exponents to the denominator. Seem like you're okay with it.
Okay,
Try this again tomorrow.
so y equals 1/x squared. I need to bring it out of the denominator into the numerator, so what does that change it to?
Negative.
Y equals x to the negative second.
Yeah.
So y prime would be what? Negative 2x to the negative third.
Because -1.
Because minus 1. And then we have to make it nice and pretty as what?
-2/x to the third.
Negative 2 over x to the third. Now you thought last week that derivatives were going to be absolutely horrible, correct?
I don't think I ever thought that.
You really never thought if you had to continue to do the limit method every time?
I mean, we've had to do more meticulous things for longer.
I'm still very slightly confused by this.
Well, stop it.
What's confusing you?
I understand when you take it out of the denominator, and then you make it negative. And when you -1, you put the exponent in front of it. But then what do you do at the end? Like, why?
Because you can't have a negative exponent in your answer.
Oh, so then you just put it back in
Yes.
the denominator. Why does the x go back there? Because that's what it's attached to.
Yes.
Okay.
See, you got it. Okay, so find the slope
What is wrong with you?
when x is -1, 0, and 1. So we want the slope of what? What didn't I say? Of the tangent line. So that means I need to find the what first?
The derivative.
The derivative.
That's 4x to the...
Oh, I touched the thing.
Oh, did you?
Yep. Okay, so y prime is 4x to the third. So that's the equation of what?
Of the slope.
Of the tangent line.
Of the slope. Of the slope of the...
And now the slope of the tangent, m sub t, how do I find it?
Numbers.
Plug them in, right? So -1 would be 4 times -1 cubed, which would be -4. And 4 times 0 cubed. Tangent. M sub t is tangent. And 0 would be what? 0. And 1 would be
Or big guys.
and then if I actually wanted the equation, I'd have to give you a point, right?
Yes, you would.
If like I wanted the equation of the line through -1, I'd have to give you a point also.
But you didn't.
Nope, I didn't. Questions?
Are you just ignoring the cube part?
Well, -1 cubed
Oh,
is...
I get it. Don't worry about it.
Okay, now find the equation of the tangent line when x equals 2. So, we've got to find, in order to find the equation of the tangent line, because tangent lines are linear, yes? Cal, you're being distracting.
Thank you.
So what's the equation of a tangent line going to look like? What form is it going to be in?
I'm not supposed to be.
Okay? Yes?
Yes.
Because tangent lines are linear. So I first need, I can find a point using -2, yes?
Yeah.
But I also have to find the slope at -2. So I have to find the what first?
The slope. The point.
What do I have to
The
find?
equation of the tangent line.
And what is that?
2x.
Well, I can't find the equation of the line until I have the slope of the tangent line. And I can't find the slope of the tangent line until I find the equation of the slope of the function. So what is that called? What am I going to find? The derivative. So f prime of x equals 2x. So now my slope at -2 is going to be 2 times -2, which is going to be -4. But I also need to find an xy, yes? But that would be plugging 2 into the original equation, wouldn't it? So it'd be -2 and
No, just 4.
just 4. So now that I have a point and a slope, I can use the point slope formula. So y minus y equals slope times x.
Plus 2.
And so add 4, so y equals -4x. And just -4x, isn't it? No,
No.
-4. Sorry, I forgot to multiply by 2. But again, guys, this question will be on almost every single test you take this year.
This exact question.
Might be a different equation.
I'd actually prefer this.
This exact one. Questions? Am I good? Natalie, am I good?
Oh yeah, you are, sir.
Okay.
You're great.
Okay, so now we have the constant multiplier rule, the one I was skipping to, which I really hate that they do this two different. What was the coefficient of every single one of your examples? 1. Okay, so when it's not 1, what do you think you do with the two numbers?
The two numbers.
Multiply them. Just like when you did logarithms, right? If there was a coefficient and you brought down your exponent, you would multiply. Same thing. Okay, so all this says, there's a lot of words just to say, the derivative of a constant times a function is the constant times the derivative. In other words, it is the constant. I think last time it had x to the n, right? So if I have y equals cx to the n, y prime equals c n x to the n minus 1. Might be a little easier to read. Just multiply them. Cn. Now, what's underneath you do not need to write down. It's just the proof of this. So if I plug everything in and I have the constant times the function, you bring out, you factor out the constant, you do all the work, and you are left with the derivative times the constant. So we are never going to have to prove them. I just want to show you that is how you prove them. If somebody would ask you to prove a derivative, you would be using the limit method. That is the proof. All the rest of them are just rules that work. Am I good?
Yeah.
No,
Are you writing the proof?
no, kind of. No, I'm not writing the proof.
You're writing.
Words. Okay.
Too many. Okay, am I good?
Yeah.
Okay, so on your assignment, it's going to have it has columns. It has a bunch of problems and it has columns. And it says rewrite, derivative, simplify. Okay, that's what we were doing. Do not worry about the columns. Just do the problem, okay? So y equals 2 over x. What's the first thing we need to do?
We need to get x in the numerator.
So it's going to be 2x to the negative first. So then I multiply. I'll write this one out and then I won't write them all out. It's going to be 2 times negative 1 x to the negative 1 minus 1. It's about probably the last time you're going to get me to write that out.
Okay.
Sorry. So y prime equals negative 2 over x squared. And I kind of skipped a step, but you know where it happened. Hopefully you guys are going down rather than sideways. I don't know. I put so many on a slide. I went sideways.
Just because you were.
Don't do it sideways.
Oh, look what you caused.
A bit late for this one.
Okay. After this, go down.
Well, I already wrote them, so.
It will be much easier if you do. Okay. Do I need to do anything with this 4/5?
No.
No. If you looked in the book, they would rewrite it as 4/5 t squared off to the side, but does it really matter?
No.
No. Okay, so you're going to take 2 times 4.
8.
So f prime of t is going to be 8 t to the, because minus 1, so first over 5. So 2, the square root of x is going to be rewritten as
2x to the 1/2.
so half of 2 is
1.
1. And so then we have to subtract 1, so we'll have x to the negative 1/2.
1 over x
So
to
then,
the half.
but we can't, oh my gosh. That would be 1 over x to the 1/2, but we can't have a fractional exponent either.
No, so.
So what would I have, that's the square root of x, right?
So you multiply the whole thing by
The square root of x. So we have the square root of x over
x.
x. You will get to the point where you see those fractional and rationals, your mind just interchanges them. Hopefully by the end of this week. If you need more of these rules this week, because I've given you one assignment, If you need more, the bottom two are from last week. I forgot to erase them. If you need more, please let me know and I will assign you some IXLs. Because if we get these down when we go on to our product, our power, our quotient, our chain, all those rules, this needs to be like multiplication. That's how fast this needs to come. Okay? So after you do the assignment, please let me know. It'd be nice. I would like it done by Wednesday so I can grade them.
I'll do IXLs if we get bonus.
Well, I probably could make that available.
Okay.
But this needs to be like your multiplication, guys, okay? It needs to be that quick. Okay, what do I got to do this next one?
You still need to move X to the numerator,
Can we bring the 1/2 by itself?
I suppose.
Okay, and then it would be x to the negative what?
2/3.
2/3. So I multiply 1/2 by negative 2/3.
Yeah,
So that's going to be negative, right?
that'll be,
The 2's are going to cross out, so that'd be negative 1/3.
Yeah.
And if I subtract 1 from here,
you get 5/3, maybe 5/3.
it'd be negative 5/3.
You get
Negative 1
-1
over 3. And I'm just going to leave it 5/3 again, still, for a reason. Okay, what do I need to add to 5/3 to get to the next whole number?
1/3.
1/3. So if I do x to the 1/3 and x to the 1/3, I'm running out of room. I'll put it down here. So I would have negative the square, not the square root, the cube root, yes,
Yeah.
of x over 3. But I'd have 5/3 plus 1/3 is what?
6.
6/3, which is
2.
2. Why would I what?
Why'd you add the 1/3?
Because you can't leave the rational this in the denominator.
Oh, so you
That's the rational.
You're rationalizing it. Now I need to put more slides and less on one slide.
I think this is fine.
Okay, so y equals negative 3x over 2.
Oh, yeah, it does.
So bring out the 3. Well, do I even need to really bring out the 3?
No,
No,
because
it's just going to be there, right?
there's going to put it there.
So y prime is what?
-3/2.
Does everyone else agree with that? Because 1 times 3/2 would be 3/2, right? And 1 minus 1 is 0. And anything to the 0 is 1. So this would be 1 minus 1. So it'd be 0. So it'd be 1. Questions? Is it going to take a minute to get your brain to be doing it?
Yes.
Yeah,
It's taken about a couple minutes
couple minutes.
so far.
The constant multiplier rule and the power rule can be combined to this, and this is what I wrote on the last slide, was it not?
That is.
When I wrote it my
Oh,
way?
Yeah.
Yep. So here are more examples. Just a second, I want to see something. Okay. How are these different? Like, let's talk about how these problems are different. What's the difference between A and B?
Well, in A, the 2 is not cubed. In B, 2x as a whole is cubed.
Right. So here we would have 5 halves x to the negative third. Yes? So then y prime would be what? Negative 15 halves x to the negative fourth. So negative 15 over 2x to the fourth. Correct?
Yeah.
But what's b? It'd be 5 what?
5/8.
5/8. So y prime would be negative 15 over 8x to the fourth.
Yeah.
Okay, I just want you to see that difference. So these problems aren't any different than we just got done doing, are they? The only difference is you have that. Okay, now C and D, what's the difference?
Same thing.
The same thing. This negative is only on, so this is actually 7x squared over 3, isn't it?
Yeah.
Yeah.
So y prime would be what?
Y prime would be 14x over 3.
Okay. But this one would be 7 times 9 x squared, would it not?
Why is it times?
Because we moved the whole thing.
Because you moved the whole thing up?
The other one.
Yeah, it was. 7x
Junior
squared
high
is
football
multiplication.
boys and girls are dismissed. All junior high football players are dismissed.
I can't hear.
What did you say?
When we moved this x up, wasn't it multiplication right here? 7x squared, that's multiplication between the 7 and x squared, isn't it?
I mean, like with the first two we did. What makes them different? Just the
Because we
negative.
didn't move.
We didn't move the x up.
Because when we moved, we just wrote it a different way while it's still being in the denominator.
But it's still the same thing. Not really.
I'm really not quite sure what you're asking.
So like A and B and C and D are the same problem generally, right?
Well, A and B, they're a division problem because the cube is positive. C and D are actually multiplication problems because of the negative exponent.
Okay.
Is that what you were
Is
asking?
that why you did them different?
Yeah. So then y prime would be 2 times 14 times 9. Right? All right, 14 times 9 because it's 2 times 7 would be 14. And this would be just be x. So 6 carry a 3 is at 126. I think.
90 plus 36, yes.
Mm-hmm. Okay. So watch your parentheses. Do they make a difference? Yes. Only move what it's on. Okay, so all this says, guys, is if you have a parabola, not a parabola, a polynomial, there's my words, a polynomial, I just take the derivative of each part of the polynomial. So if I was going to write this down, I would just write plus and minus. I would not write two different definitions. Does that make sense?
Yeah.
So the sum and difference rule is right here. If you have a polynomial, you just take the derivative of each part and combine them. That's it. Now, since we are subtracting 1 from each power, your polynomial is going to go down by how much? 1 degree. So if your polynomial started off as an odd, your derivative is going to be a what? Even. Yes? Does that make sense? If it started off as an even, your derivative is going to be an odd function. Are we good to start the examples, Natalie? Okay. So we have f of x equals x cubed minus 4x plus 5. I want the derivative. So f prime of x is going to be the derivative of each part, not all together. So the derivative of x cubed is what?
3x squared.
3x squared. The derivative of negative 4x is
Negative 4.
negative 4. And the derivative of 5 is
5.
nope.
Okay.
It's the first rule you learned today.
0.
0. So your derivative is 3x squared minus 4. Your function was a cubic, your derivative is a quadratic. If your function was a 6th degree polynomial, your derivative is going to be a 5th degree polynomial. Ooh, try the next one on your own. T's are looking kind of like Z's. So did you guys get negative 2x cubed plus 9x squared minus 2?
Yes.
Thanks.
He was checking your paper.
Thanks.
Okay. So really, is this anything different than just do it by parts? That's it. Okay. So you need to know these. We already know that limits, they had special things with trig, yes? So the derivative of a sine is cosine. The derivative of cosine is negative sine. And you will mix up those all the time. So don't.
Oh, will I?
Hopefully not. Prove me wrong, please. So the derivative of 2 sine x.
Oh, that'd be 2 cosine.
Would be 2 cosine x. Because 2 is the coefficient, right? How would I rewrite this, or at least think about this? Do I need to worry about the 2?
No.
It's just a half. It's off to the side, right? Or it's right there where it's at. So y equals sine of x over 2. What is the derivative? Cosine x over 2.
Cosine x over 2.
So you just split the sine and cosine and cosine and sine?
Mm-hmm. But cosine's negative sine. So now we have 2 derivatives we've got to do, right? So what's the derivative of x?
One.
1. You'll forget that in a week. For some reason, we all try to forget that. I'm like, really? It's just 1. Okay? And then the derivative of positive cosine of x is negative sine of x. That's it.
We're done?
Well, I don't know if we're done, but that's it on that.
Why
I
was
already
it
put
1?
my pens away.
Because there's a 1 up here. So it'd be 1x to the 1 minus 1 And 1 minus 1 is 0, and anything to 0 is 1, and 1 times 1 is? Okay. Rate equals distance divided by time, correct?
Sure.
Or, well, it does. Distance equals rate divided by time. Rate equals distance divided by time. You know dirt.
I don't know dirt.
You don't know dirt?
No, I don't.
You don't know distance equals rate times time? You don't know that?
Oh, now I do.
Okay. Typically, I would say distance equals rate times time, and I would move it around. Because that's what I've learned. That's what I was taught, like 6th grade or something. Okay. Velocity, average velocity, is the change of distance divided by the change of time.
This is a physics class.
Well, it essentially is. So was trig, so I don't know why you guys didn't take physics this year. Yeah, it was. It was dropped because only one person signed up.
Who was it?
Ethan. Okay, the function S gives the position relative to the origin of an object as a function of time is called the position function. Okay, so this right here is a position function. Over a period of time, it's change of delta time. The object changes position, the amount of the formula. Then by familiar formula, distance equals rate times time. Okay, so those are those two things you need to know. Velocity, guys, is the derivative of the position function. So if we get a position function and we want the velocity, we take the derivative. And then you plug in the 6 seconds, and it tells you the velocity. Okay, think about it. A derivative function is a slope, right? An instantaneous rate of change. Wouldn't that be exactly what velocity is?
Instantaneous velocity.
It's the same thing. Good? I guess. If a billiard ball is dropped from a height of 100 feet, its height is s and its time is t is given by the position function. So this is the position function. They've already taken in account for gravity. We will later on do that, and you will have to know gravity, the rate at which it affects an object.
You will have to know that.
Where s is measured in feet and time is measured in seconds. Find the average velocity over each of the following time intervals. All you're doing is finding the derivative and then plugging in your time. So, S prime would be negative 32 t. Guys, that's gravity. So it'd be negative 32 feet per second. And it's still negative 32 feet per second.
Wait, so it doesn't even change with any of those three? Because you're plugging in.
What did I do
X would
wrong?
be T, right?
Oh, find the average. No. Sorry. This is an interval, yes? So you have to, this is the 1, and then you have to plug in the 2. So that would be negative 64 feet per second. So the average would be 32 divided by 2, which would be 116 feet per second. Sorry. Because these, no, these are both x values when they talk about an interval like that. So you have to, or t values. So you plug in both and find the change. We'll work on it. We got tomorrow.